Okay, let's get started here. I've created a new project, and inside of that project, I went and created a folder called scenes, and I saved my scene inside of that folder. What I want to do now is bring the models from Blender into Unity so that we can set up our basic arrangement, and then we'll start coding the movement of the platform. For that, I'm gonna go here and create a new folder called models. In case you're not familiar with Blender, it's a free open source 3D modeling package that I've used to create the models for this game. Covering Blender is outside of the scope of this course, but I know that many of you are Blender users, so I will show you how I export my models from Blender so that you can do the same thing, and so that process at least is clear if you are a Blender user. So I have Blender open, and I have the two assets that we will import into Unity. One of them is the terrain and the other one is the platform. So I'm going to begin by exporting the terrain. What I like to do is select my model. So you can press A and make sure it's selected, and then go to File, Export, FBX, which is a file format that is compatible with many other applications. Then you find the folder where you want to export this file. In this case, I've already located the folder models inside of assets. You give this a name. This is going to be called terrain. And in this area here, make sure that selected object is checked, the scale 1, and also this button is it's light like so, it's selected like so. Then export the FBX file. In Unity, if you go into your models folder, you'll see the terrain, and you're also going to see that a folder called materials was created, which contains the materials that were used in this terrain. What I'm going to do now is drag my terrain onto my scene so that we have our nice terrain in there. Okay, now I'm going to do the same thing with the platform. So I'm going to make sure that my platform is selected. I'm going to go to File, Export, FBX, and then I'm gonna give this a name. It's going to be called platform, and I make sure that it's selected object, that this thing here is selected as well, scale 1. I don't touch any of the options in here. I'm going to export that. You can see that I have both in the same file, and if you had different elements, it's always good to make them share the same materials, because that will help with performance in Unity. So if you have different elements that use the same material, make sure they're actually the same material in Blender. Okay, so we have our platform, and I'm gonna drag my platform in here. We can see that our platform looks very big in comparison to our terrain. Our platform is actually two Unity units of size approximately, or actually exactly. It is almost two Unity units in each side, which means 2 meters. So that basically means that our terrain is a little bit too small. We should give it a bigger scale. So I'm going to scale this to, I think 2 might be enough. Let's see. And I think that is a good amount. So let's get our platform again and bring it up. And now it's obviously not real size. I think that this can be made even a little even bigger, like 3. Yeah, I think that is much better. Okay. So we have our platform now, and I want to talk about how you work in virtual reality with the camera. In a normal 3D game, so let's bring our drawing pad for that. In a normal 3D game, you usually have your camera, and then you have your player that moves around, and that is in a third-person game, so that will work in a similar way in virtual reality, with the only difference that this camera, that this is actually you. So wherever you are looking is where the camera is looking. But in a first-person game, it's also the same way. It's as if you have the camera on you as you walk around. And in this case, this is a first-person game. You will be positioned in this platform, surrounded by those rails. But the big difference between normal 3D games and virtual reality games is that in a normal 3D game, you can move the camera, and you can move the transform of the camera. You can move the camera, you can rotate the camera, you can move it up and down, change its transform basically. Whereas in a virtual reality game, The camera only moves when you move. For example, if you move up, then the camera will rotate to that direction. So you can't impose that sort of movement in virtual reality. A golden rule in virtual reality, and at least I haven't run into a situation where this doesn't hold true, is that you never, actually never, ever, ever modify the camera's transform. So what do you do then if you want to have this platform moving around? What you do is that you put your camera, this is meant to be the camera, you put your camera inside of another game object. And it is that game object that you can move around. So you can move a parent object. And that is the approach that we will be taking in our game. Now, why exactly, you might wonder, is it that we cannot or that we should not modify the camera's transform from during our gameplay directly? And the reason for that is very simple. Your HMD, your head-mounted display, will pass on to Unity the rotation according to where you're looking at. So if you're looking up or you're looking down, that involves a rotation in the camera, and that is being passed. So if you try to set that at the same time, you are going to be causing a trouble here, because you're going to set a value, but then the head-mounted display keeps on passing on its rotation based on the tracked rotation. So that is why you shouldn't do it. And what about position? Well, if your head-mounted display has position tracking and you have, say, a 1 meter by 1 meter kind of area where you can move, it is that positioning there that is also going to be passed by your head-mounted display. So your head-mounted display might also be passing position and rotation. Those are reasons why you don't want to, and you should not modify those values. So those are technical reasons, because if you try to do it, the value that you enter is going to be immediately replaced by the current value of the HMD. But then also from a comfort perspective, I'm going to give you an example. Imagine that in real life, instead of you being able to look around wherever you want, there was some sort of hand that comes from the sky and that just rotates your head. That would obviously feel horrible, and you would feel very disoriented and sick, and you would not enjoy that experience. So there's also a very strong comfort argument why that is something that should not be done. If in case it could be done, in case you could somehow disable, and you could disable the SDK connection, the connection between the SDK and the camera, but that would make absolute no sense. Whereas the concept that we're going to be using, which is to put the camera inside of another object, makes a lot of sense even from a real world perspective. Every time that you get into a car, what you're doing is exactly that. You are positioning your own camera, your own person, inside of another object that can move, that can rotate, and it doesn't feel, it feels okay, obviously, except if you start spinning. But that is the main argument here, and that is the analogy with the real world. If you get into a car or an elevator or any kind of vehicle, an airplane, you are getting into another game object that is moving, but you are not being moved by other forces. You're not being rotated. Your head is not being forced by an external hand that tells you where to look at. So those are the main arguments why we are going to have this approach in our game. So let's go back to Unity and let's create an empty game object, which I'm going to call player. And inside of that game object, I'm going to place my camera so that we know that we can now move our camera. We also want to move our platform at the same time that we move this player, because that is how we are going to move in this world. So I'm also going to put my platform inside of this player object. And I'm going to set the coordinates of this platform to be 0, and the coordinates of the camera to be 0 as well, so that everything starts at the same position. And by the way, when I say don't modify the transform, that is during the gameplay, but obviously before the gameplay you do have to position your camera somewhere. Although the rotation is something that you can't control because the player is the one that's going to be rotating, but you can control our original position, although that will also depend on different headsets, there might be some differences there that will be covered when the particular headset is covered later on. Okay, so let's have this arrangement, and let's think that our camera shouldn't be ground level as it's shown here on the game preview. So I'm going to drag the game here. It should actually be somewhere at a normal height of a person, and that again will depend on the headset, because on the HTC Vive the camera is the height is also given by the height of the player, but that is not the case in the other headset. So let's go with this approach, and then if we need to modify something for a particular headset, we'll do it when the time comes. Okay, so we have now something going, and then you are able to move this parent object, and that is how we are going to be moving in this virtual world. What we are going to do next is start our script so that we can move towards a target. I'm going to go here and create my first target. Create empty, and let's call this target. And position this somewhere. It's an empty object. The only thing it has is a transform. It doesn't have any renderer, so it doesn't appear on the game. But it is what we will use to position the targets of this virtual tour of our platform. So we want to move here first. That will be the very first point in our tour. Okay. For that movement, we will create a C# script. So I'm going to go to Assets, and I'm going to create a folder for my scripts. And inside of that folder, I'm going to create a script which is going to be called Player Controller or Platform Controller. So let's open that in our code editor. So I'm going to be using Visual Studio. And there are a few things here that we will be needing. One of them is to be able to pass on that target. And that target will be a position. It will be a vector 3. So we're going to have a public vector 3, which is going to be called target. So this will be the movement target. Something else that we want to have specified as a parameter is the speed of our platform. And that will be a float. And I'm going to set a default value of 1. Then there is we will be updating the position of this platform in our update method, which is executed on each frame. When we will be moving until we reach that position. And one way to do that is to calculate the distance between our current location and that ending position, and see if that distance is greater than 0. If the distance is greater than 0, it means we haven't reached it there yet, so we should keep on moving. So I'm going to write it first and then implement it. We want to calculate the distance from our target. And also we want to check if we have arrived. So have we arrived? And if the answer is no, then what we want to do is calculate how much we need to move. So this what I'm going to call the step. And then we need to move by that step. Okay, so let's put this in a variable, the distance. And an easy way to calculate the distance between 2 points is by using a method that comes in the vector3 class called distance. So I'm going to go to help, and I'm going to go to the Unity API reference, and I'm going to show you that method called distance. So if we scroll down, we'll find that distance here, and that will return the distance between 2 different points. So that can be easily calculated by using algebra and geometry, and this method does it for us. So let's use that. Let's make use of that and type vector3.distance. The position of our position is transform. Transform.position, and the other position in space is going to be our target. Cool. So we have the distance. Now, have we arrived? Have we arrived? We can know that by checking if the distance is greater than 0. So if that is true, it means that no, unfortunately, we have not arrived yet. So if we have not arrived yet, then how much do we need to move? And from physics, from school physics, you might recall that the speed is equal to distance divided by time. So we know the speed because we are setting that value, and we can know the time in between update calls by using the delta time property. So that gives us the answer for our step, which is d, will be equal to the speed times the time that has passed. So by using that, the distance will be equal to the speed times the time, we are going to define our step, and we are going to get that by multiplying speed times time dot delta time. So that is the time that has passed since the last time that update was called. All right. Then how are we going to move to that position? Well, an easy way to do it is by setting the position to use. We can use again vector 3, and there is a method here that's quite useful, which is called move towards. So I'm gonna find it in here. In the documentation, we have move towards, and what this vector does, it moves a current point in a straight line towards a target point, and you can give it how much you want to move. So we can tell it move from the current position to the target by this distance that we are telling it to move. So if we type here move towards, and the current position is transform.position, the target destination is target, and the step that we need to move is step. We've just calculated that. Okay, so now we can go to Unity and see if this works with the elements that we have in here. So the very first step will be to drag our script onto our player. And now if you go to your player, you will see that there is the platform controller here. And actually, when you have vector 3 as a parameter, it brings you x, y, z, which are the properties of vector 3. And what we actually want is to be able to pass on our object. So for that, we need to set that as a transform instead. So what I'm going to do here is set this as a transform, because all Unity game objects have a transform component. So that transform will give us access to the position. So now, instead of using target like that, we need to type target.position and do the same thing here. Okay, so let's go back to Unity and click on player, and you will see now that you have that target that you can drag an object in there, a transform object. So our target, the only thing it has is a transform, so it is definitely something we can use. So I'm gonna drag my target onto that target location, and now I'm gonna press play just to see what happens. And effectively, we are now moving to that direction. Before we go into the challenge, I actually want to refactor our code a little bit and prepare you for the challenge that is about to come. So all of this code here has to do with movement, and we still need to add the user input. So I'm going to be creating a new method here, which will take care of the movement. So I'm going to call this handle movement. And I'm gonna grab all this code and I'm gonna put it in handle movement so that we can have all the code that has to do with movement in one place. And then we will be calling that from here. So this is going to move our platform. Above movement, we will also check for input. And we're gonna call this method handle input. Visual Studio will complain that it doesn't exist, but I'm going to press Ctrl dot and be lazy and have Visual Studio create that method for me. So we have that method there, and it will be up to you to complete the contents of that method. And so how is this going to work? We are going to have a private variable here that is going to be a flag that sets whether we are moving or not. This is going to be a Boolean value, and it's going to be called isMoving. And it's going to start as false. So we're no longer going to start moving. And the way that this input method will work is that it will detect the user input, and according to that user input, it will change this property here to either true or false, and according to the value of this property here, we might or might not be moving in this part of our code. So let's go to the challenge. The challenge will consist on implementing this handle input method. That in there you have to detect whether the fire1 input axis has been activated. So a quick explanation about that. If you go to edit in your project, and if you go to project settings, input, you will see all the input axes, and there is an input axis which is the fire1, which is in the keyboard. It is left control or the right click of the mouse. So we're going to be using that one, fire1. So you have to check if fire1 has been activated, and if that is the case, swap the value of isMoving, so from true to false or from false to true, and then go to handle movement and move only if isMoving is true. So have a try at this challenge, see how far I hope you can do it, but if not, that is okay. I'll be here and I will show you the solution. So pause the video and try this challenge. All right, welcome back. So let's go and solve this challenge. We want to detect whether that button has, that input axis has been activated. So inside of our code, inside of handle input, we are going to check whether the input axis has been activated, and so we're going to check for the fire1 axis. And one way of doing that, there are different ways of doing that, is going to be using input.getButtonDown. So if you're not sure of what method to use, you can always go to the Unity documentation and find all of the methods that exist for that corresponding class. So input class is the one that has to do with user input, and that gives us getButtonDown. And because we're using an axis, that is a very flexible approach, so that different devices can be tracked to a certain axis. So in this case, it's fire1. Even that gives players more control, because there might be a new device in the future that you don't know that's coming yet, and that might also use this fire1 axis. Whereas if you use specific keys or mouse events, those things might become obsolete. So that was the first part. It was just detecting if that is pressed. And if that is pressed, we want to basically negate the value isMoving. Negating means, so we're going to negate isMoving. It means setting it from true to false or from false to true. And an easy way of doing that is by simply setting it to its opposite by using the exclamation mark. So that will turn isMoving into its opposite. The third part of the challenge is to modify handled movement and only move if isMoving is true. So we're going to go into handled movement, and only if moving is true, we're going to continue, which means that if we are not moving, exit, basically by checking that if. There are different ways of doing that. You can also make the check outside of the method, but I'll do it here. So you can check that if isMoving is false, basically, we're just going to return. We're going to exit this method. And now if you go to our game and see if this works, let's have a play. Let's have a go here. So I'm not moving at the beginning, and that is what we intended. I'm going to press the right click and we are starting moving. And now if I press that again, we stop and we can resume our movement. So we've solved the challenge, and now we're ready to move on to the next lecture, where we will be adding multiple stop points. Basically, you can have a whole circuit around your landscape. So I will see you then.